Higher derivatives. It is possible to take the derivative of a derivative, and this would be called f prime prime or to the second derivative. But you can also take the third derivative, fourth derivative, fifth derivative, depending on what you're being asked in the question. So here's some notations for second derivative. So for the first 5 derivatives, it can also be written in terms of the prime. So first derivative is f prime of x, f double prime of x, f to the third derivative, fourth derivative, and fifth derivative. In our first example, it asks for the first 4 derivatives of f of x. So we have 2x to the fifth minus 3x to the fourth plus 12x. So the first derivative would equal 10x to the fourth minus 12x cubed plus 12. The second derivative, again, you take it from the first derivative, becomes 40x cubed minus 36x squared. The third derivative, 40 times 3 is 120x squared, minus 36 times 2 is 72x. And the fourth derivative, again, applying the exponent, so the fourth derivative equals 240x minus 72. In the next example, you're asked to find the second derivative of the expression y equals the square root of 3x plus 1. And then after you take the second derivative, you will substitute x equals 5 into the expression. So the square root, we change that so that it reads y equals 3x plus 1 in brackets all to the 1/2. And here we'll have to do the chain rule. So the first thing you'll do is you'll bring the power 1/2 to the front, subtract 1 from the exponent, and then take the derivative of what's inside the brackets. So that's the chain rule. The 1/2 comes in front, 3x plus 1 remains in brackets, and we subtract 1 from the exponent, so the exponent is now negative 1/2. The derivative of 3x plus 1, the derivative of what's inside, equals 3. So simplifying this further, I'm going to combine and multiply 1/2 times 3. So 1/2 times 3, so the first derivative will equal 3 over 2, bracket, 3x plus 1, bracket, all to the negative 1/2. Here I have to now take the second derivative because that's what the question asks me for. So again, I'm going to apply the chain rule, multiplying 3 over 2 times the exponent of negative 1/2. Subtract 1 from the exponent, so minusing 1 is minusing 2 over 2 because I need to convert that to a fraction, and that's how I get negative 3 over 2 as my exponent. Times the derivative of what's inside 3x plus 1, and that equals 3. So let's take a look at this again. I apply the power to the fraction in front, 3 over 2 times negative 1/2. Subtract 1 from the exponent, so I subtract 2 over 2, and that's what yields me negative 3 over 2, times the derivative of what's inside, which equals 3. Simplifying this, I have 3 times 3, which is 9 in the numerator, negative 9, and 2 times 2 in the denominator is negative 9 over 4. Since I have a negative exponent of negative 3 over 2, I'm going to bring 3x plus 1 down into the denominator and use my exponent law to change it to square root 3x plus 1, all cubed. That's your grade 10 exponent law that you learned. Now what I need to do is plug in x equals 5 into the letter x. By substituting in, you can see I've placed it in there in red. Negative 9 is the only thing in the numerator. And in the denominator, I have 4 times the square root of 15 plus 1. Well, 15 plus 1 is 16. The square root of 16 is 4. 4 cubed times 4 again equals 256 in the denominator. So the answer of y double prime, substituting in 5, is negative 9 over 256.